Photovoltaics, the Bright Future of Renewable Energy Sources by Matthew Volkman. The amount of energy radiated from the sun is enormous. Photovoltaic systems are the simplest and most direct way to convert solar radiation into usable electric energy. Despite their modest beginnings, photovoltaics are gaining ground on many fronts and are nearly to the point at which they can offer electric power for a rate that is similar to that of conventional energy sources. This paper will explore their history and scientific underpinnings, implementation of residential systems, photovoltaic power plants and their future, economic and political considerations, and more complex issues like their efficiencies versus costs, environmental concerns, and durability issues. First, I'd like to cover a general overview of the points that will be covered during the course of this presentation, including history, including the scientific underpinnings of photovoltaic systems, the types of photovoltaic panels that are available, residential systems, power plants, and then a summary of conclusions. Humanity's earliest solar ambitions were first made possible through a more detailed scientific understanding of the nature of light. This understanding was first articulated in the typical elegance of a scientific formula, postulated by none other than Albert Einstein. This formula wasn't for his famous mass-energy equivalence, but rather for something called the photoelectric effect, which is defined, most simply, as the tendency for certain metals to emit electrons when light of a sufficient energy is shined upon them. It is these free electrons that photovoltaic systems use to create an electric current. In 1954, three researchers working with semiconductors for use in telecommunications accidentally discovered an efficient method of converting solar radiation directly into electric power through use of silicon doped with certain impurities. The apparatus was only 6% efficient, but despite that, NASA sought the technology to use in their orbiters. Slow advancement took place over the next 20 years until new methods of applying light-absorbing material were discovered, achieving efficiencies in the low teens. More recently, researchers using combination of technologies, including refraction and intensification techniques, have focused lights of higher power into a smaller area and achieved higher than 40% efficiencies. There are several kinds of photovoltaic cells. Silicon-based are probably the most familiar, as they are what we've seen attached to rooftops in lower latitudes for some time now. Thin film panels are typically composed of a sheet of substrate, usually foiled, sprayed in a vacuum with different layers of the light-absorbing materials that make them work. Those materials include gallium arsenide, copper indium gallium diselenide, cadmium telluride, and amorphous silicon. Concentrating photovoltaics, as mentioned earlier, are a synthesis of mirrors and usually small, thin-film photovoltaic cells. Silicon-based photovoltaics require a bit more dissection. There are three main types. Monocrystalline have high efficiencies, but are difficult to manufacture and have a high cost. Polycrystalline have lower efficiency, but are easier to manufacture and therefore have a lower cost. Thin-film amorphous silicon are highly durable with very low efficiencies but are very easy to manufacture. We see these examples in our wristwatches and calculators. Residential systems are quickly becoming a viable power generation method all over the world. This is driven in part by scientific advancements in making the technology cheaper, partly by economic incentives put in place by local, state, and national governments, as well as by utility companies, and partly by the phenomenon known as the Green Revolution. Over the past 10 years, we can see that the number of photovoltaic system shipments has gone up by nearly 10 times. Obviously, photovoltaics are an integral piece of a desire to greatly reduce carbon dioxide emissions. There are several considerations that need to be looked at when thinking about installing a residential photovoltaic system. Latitude, or degrees north and south. The sun's energy is lessened at higher latitudes. Typical energy consumption. The typical energy consumption for a home will dictate the size of the system that is required to power it. Unshaded property. Because panel efficiency and collection time can be reduced greatly by trees or clouds. Grid-tied or off-grid. Grid-tied systems allow the homeowner to actually sell power back to the utility, and typically incentive rebates offered are greater for grid-tied systems. Off-grid systems are easier in remote areas. Panel efficiency versus cost. In a home installation, where square footage is limited, watts per square foot is of the utmost concern. But cost is a factor for almost everyone. Trackers fits under this category too, as they are expensive. A tracker is a device that allows a photovoltaic panel to track the path of the sun as it paves through the sky. Some of the largest photovoltaic power plants are in Spain and Germany, but there are 2 huge systems planned for California in the next year. This is Spain's Olmedilla Photovoltaic Park in Olmedilla de Alarcón. Its 162,000 panels provide 60 megawatts of power at peak intensity. This is Straßkirchen Solar Park in Germany. It is the world's second largest, with a generating capacity of around 50 megawatts. California has 2 projects in the works, Topaz Solar Farms and California Valley Solar. Topaz will put out about 550 megawatts and California Valley Solar about 250 megawatts, and they're both scheduled to go online in 2011 and be fully operational by 2013. One option for photovoltaic solar plants is to launch a photovoltaic array into geosynchronous orbit around Earth and beam power via microwave back to Earth. The project has 2 things going for it. 1, the amount of solar radiation in space is about double what's available at the surface. And 2, in space, sun never sets. Photovoltaics are an excellent choice as the world moves towards a low-emissions power generation paradigm. Photovoltaics are scalable, from the smallest PV cell in a wristwatch or calculator to the 550 megawatt power plant slated to go online in 2011. The technology is also extremely versatile, as it can be used anywhere the sun shines, including space. The technologies that are related to solar efficiencies are getting better at an astonishing rate. As a result, prices are dropping as manufacturing techniques get better and better. All in all, photovoltaics have a lot of room for growth and nearly limitless promise, and do indeed have a bright future.